one very popular implementation of stack is towers of Hanoi problem. Let me explain towers of Hanoi by a video. क्या कह रहे हो सर आप? What are you saying, sir? Towers of Hanoi. So this is the Towers of Hanoi game. You know the rules? How many of you know the problem? Anyone who don't know what is the problem? किसको नहीं पता what is the problem? You don't know what is the problem. See, there are three towers. This is tower A, this is tower B, and this is tower C. I can say this is tower A, this is tower B, and this is representing the tower number C. Now you have to transfer all these plates from tower A to tower C in minimum number of steps. Correct? But the limitations are you can pick one plate at a time. You cannot pick more than one plate, just one plate at a time. Second limitation is on a smaller plate you cannot have a bigger plate. So on a smaller plate you cannot have a bigger plate. So this is the limitation. Now there are multiple ways you can do it. Okay, the first way can be you can put this here, you can put this here, you can put this here, put this one here, then put this one here, and this one. So total of we have done with the 7 moves. That is the minimum number of moves required. Okay, but sometime it can happen that it doesn't take minimum number of moves. Okay, I can do something like this. Put this, and then we have this on C, B, and I can have A, I can have this one here, and I can have this one here. Now instead of transferring from A to C, I transferred from A to B. This took 7 steps. Now I could have also, then I can take 7 more steps for transfer from B to C. So just to transfer these plates from tower A to tower C, it can take 7 steps, it can take 14 steps, it can take some variable number of steps. If we have not taken the right steps, then will not be able to get the correct answer. Correct? Now just like this, there's one more possibility. You can put this one here, you can put this next plate in tower number B, this is in tower number C, this is in tower number C. Okay. Now I can put this here. Now I took total of 9 steps. Instead of taking total of 7 steps, I took total of 9 steps. Okay. This was in case of 3 plates. We can have 4 plates, we can have 5 plates, we can have 6 plates, we can have 7 plates. There are so many plates, so many number of plates that we can have. Okay. So in best case scenario, if we have, this is the total number of plates n, that is number of plates, and this is number of moves, If we have one plate, we can directly put this one plate from tower A to tower C. That will take exactly one move. If we have 2 plates, right, instead of taking 3 plates, if we have 2 plates, assume these 2 plates, then we can put the first plate here, that is step 1, put the second plate here, that is step 2, and put this plate from here to here, that is step 3. So it will take 3 steps. If we have 3 plates, that will take a total of 7 steps in minimum. If we have 4 plates, that will take a total of 15 steps. If you have 5 plates, that will take a total of 31 steps. In the same way, if we have a total of n plates, that will take total of 2 raised to power n minus 1 steps. Okay. And do you know the story behind this? Yes. It is also called as Towers of Brahma. Towers of Brahma. Why? Because have you ever tried to search this on Google? Towers of Hanoi, Kashi Vishwanath temple. Read this. The Towers of Hanoi is also called as Towers of Brahma, and sometimes something. is a mathematical game. It consists of 3 rods, a number of disks of different size, which can slide onto any rod. Okay, now this is okay. Now I just wanted to see the origin. It says, there's a story about Indian temple Kashi Vishwanath, which contains a large room with 3 time-worn posts in it, surrounded by 64 golden plates. Now we have taken 3 plates. So they are saying in Kashi Vishwanath there are a total of 64 plates. So there are Brahmin priests acting out the command of ancient prophecy have been moving these disks accordance with the immutable rules of Brahma since the time. That means there are 3 Brahmins who are putting these plates from one tower to another tower since the time when the earth started. And they said when they will put all these 64 plates from the first tower to the third tower, the earth will end. So this is like this. So see, the puzzle is therefore known as Towers of Brahma. According to the legend, when the last move of the puzzle is completed, the world will end. It is not clear whether Lucas invented this legend or was it inspired by this. If the legend were true, if the priests were able to move disc at a rate of 1 disc per second, then it will take total of 2 raised to the power 64 minus 1 moves, or you can say 2 raised to the power 64 minus 1 seconds, which is roughly 585 billion years to finish. It will take 585 billion years to finish, which is exactly 42 times the current age of the universe. Okay, that is the Towers of Hanoi problem. Fine. Now, we can easily do this. I mean, the problem is very easy. Understanding is very easy. Now, my question is, can you write a program to implement the Towers of Hanoi problem? Yes. But to write a program, you have to find, see, you can write a recursive relation for this. And you can also write a non-recursive program. Can you write an iterative program? That's very difficult. That's very difficult, right? To write the iterative program, you need stacks or queues as the data structure. To write the recursive program, we need recursion, we need stacks, right? Anyways, iterative program is not in syllabus. So, we'll write the non-iterative program. Okay. To write the non-iterative program, you have to find out what are the conditions, termination conditions. Okay? Termination conditions. Do it like this. If we have 1 plate, if number of plates is equal to 1, that means you can directly take this plate from tower A and put this plate to tower C. That means if n is equal to 1, then take plate from A to C. Okay. If we have 2 plates, this is A, B and C. That means these are the number of plates. Now what you can do is take the first plate to tower B, take the second plate to tower C, and then put the first plate to tower C. So if n is equal to 2, then take n is equal to 1th plate from A to B, and then take nth plate, or you can say the second plate, from A to C, and take n is equal to first plate from B to C. Okay, this is the solution. If we have the number of plates as 3, let us suppose there are 3 plates, 1, 2 and 3. So A, B and C, there are 3 plates. The solution is put the top n minus 1 plates, put 2 plates from A to B, where A is a source and this is the destination. Now you can also make it as a source, this is intermediate, okay, or extra, or give a better word. This source, this is destination, and this is extra, let us say, this is extra. So for putting 2 plates from A to B, this will become the source, this will become the destination, and this will become extra. And then put the third plate from A to C, and then put the 2 remaining plates from B to C, from B to C. For B to C, this is the source, this is the destination, and this one is a spare. Third plate will become spare. Now if you have a total of n plates here, like this, if you have a total of n plates here, solution is put the n minus minus 1 plates in the tower 2, and then put the nth plate in the tower 3, and then put these n minus plates from tower 2 to tower 3. Okay, recursively put these n minus 1 plates from tower 2 to tower 3. So when you are putting these n minus 1 plates from tower 2 to tower 3, this will become source, this will become destination, and this will become spare. Okay, so roughly how you can do it? So anyways, how you can do it? You have to take 3 plates. You have to say towers of Hanoi. This is the function. This is the total n plates. We have to put these plates from source to destination, where one will be spare. Okay. Now you write if the value of n is equal to 1, then place plate from source to destination, from source to destination. Okay. Else, what you have to do? Put n minus 1 plates from source to spare. Put the nth plate from source to destination, and then put these n minus 1 plates from spare to destination. From spare to destination, that's it. And this program will tell what is the exact moves you have to take. Okay, can you program it? It is not in syllabus, but it's very interesting to program it. Have you ever tried to program this code? How many have done this? 1, 2, 3. Okay. So it will take 2 minutes only. Not in syllabus, but it's very interesting. Okay. So I'm writing towers of Hanoi. It will take integer n. It will take character source, character spare, and character destination. Okay. So I can just write if n equals 1, then printf put the plate from percentage s, you can take character or string, whatever you like, to percentage c to percentage c, comma source to destination. Okay, make it d small d. Okay, else you have to put towers of Hanoi, you have to put n minus 1 plates from source to spare, and that will become destination. Correct? So this is source, this is spare, and this is destination. So I am putting source to destination. I just changed the order. Okay. Then printf put the plate from percentage c to percentage c, where we have source and we have destination. Okay. And last, towers of Hanoi, put all the n minus 1 plates from spare to destination, where source will become extra. Is it okay? See, this is destination, this is spare, and this is source. So we are putting n minus 1 plates from spare to destination, that's it. Now I can just call this function. Let us say I want to put 3 plates, right? So I can just call towers of Hanoi, 3 plates. We have tower A, spare is tower B, and destination is tower C. So these are characters. Okay, so 3 plates from tower A, B and C. And slash n. Put it space here, slash n, and again slash n here. Okay. So it is saying put the plates from A to C, put the plates from A to B, C to B, A to C, B to A, B to C, and A to C. Let's check. See, we have, this is the tower A, this is the tower B, this is the tower C. So these are 3 plates, plate 1, plate 2 and plate 3. So first step is put the plate from A to C. So we are putting this plate from A to C. Hence we got, in tower A we got this is tower B, and this is tower C, we got the smallest plate. This is A, B and C. Next we have put the plate from A to B. So we are putting this plate from A to B. Okay, then we are putting C to B. So we are putting this plate from C to B. That means we got, this is tower A, this is the biggest plate. In tower B we got this plate, and in tower C it is empty. Next step is put A to C. That means we are putting this plate from here to here. So we got tower A, in tower B we got 2 plates, and in tower C we got the biggest plate. Okay. Then put plate from B to A. So that means put this plate from B to A. So this will take us, this is tower A, this is tower B, and this is tower C. Okay. Next is put plate from B to C. So we are putting this plate from B to C. This is the second plate, and then put the plate from A to C. So this is the third plate. So it will come here. Okay. So this is how you can implement the towers of Hanoi problem, and easily you can find the solution. Now you tell me, how many recursive calls will be there? How many recursive calls will be there? I'm saying exact number of recursive calls. Order up to n. That I know. If I say the value is 9, tell me the exact number of recursive calls. So आपने क्या किया? This 2 raised power 10, 2 raised power 9 minus 1. The number I'm saying number of recursive calls. I'm not. Okay, that will be same. 2 raised power n minus 1. Na? So that is just by the recursive relation from this. So we know that it is the total of number of moves required is, for n it is 2n plus 1. Okay, 2n minus 1, you can say Tn is equal to 2t n minus 1 plus 1, and you can solve it for the relation, and you can find the formula. Then you can easily do it. Okay, this is one application of one application of stack, that is the towers of Hanoi problem. Fit and fine. Now, if you know dynamic programming, my question is, can you minimize the total number of recursive calls? To what extent? Can you minimize the total number of function calls, or recursive calls? You know dynamic programming, right? All of you know dynamic programming. My simple question is, can you apply dynamic programming on towers of Hanoi problem? Can you do it? Yes or no? No? Or yes? अरे सर आपने क्या कह दिया? अरे सर why do you joke so much sir? अरे sir what are you saying sir? Sir what are you saying sir? We can apply or not sir? Okay, do one thing. Tomorrow you will give me the answer whether we can apply dynamic programming on towers of Hanoi problem or not. Fit and fine. So the next topic is queues. Right. One more topic left.